All right. Sam, is our recording button up there on your screen? All right. So go ahead, let's go to the second slide and we'll see who the speakers are. I'm going to talk for about the next 10 seconds, so you can ignore that person on the left side of your screen. But we've got Dr. Benjamin Harvey, who's the founder of AI Squared and is a tenure track professor at Bowie State, and also does, I believe you still are a researcher for Johns Hopkins as well. And then we've got Samuel Raymond, who comes to us from Australia by way of MIT, and then is now at Databricks, and he will also be teaching at a fancy school in the Northeast in the distant future in the US. So the goal of today is just to talk about LLMs, some of the work that Sam and Ben have done, and then bring that discussion into the context of academia and courses in academia. So Sam, I'm going to stop talking. Take it away.
Fantastic. Thank you, Rob. That's always a great introduction when you're involved. Welcome, everyone. And thank you, Ben, for joining us as well. It's a privilege to have you here. I think the goal of really this meetup and this talk is to discuss the role of LLMs in academia. We've seen over the last 6 months, really just this year, LLMs explode and turn into something that I don't think anyone really theorized or hoped could possibly happen back in 2017 or so, when the Transformative architecture was made public to the wider community. But we've seen something happen that I don't think many of us have really seen before, in terms of how the technology that's been produced has changed not just industry, but really the way society behaves. And in no small part, academia is an industry that is going to get impacted more and more by LLMs. Some of you have probably already seen it. Certainly, faculty have been challenged by large language models and the different applications that have been built on top of them. Personally, so my role at Databricks, I'm a data scientist where I work with our customers to implement novel solutions with machine learning models, and then this year with LLMs. I also co-wrote and am a co-instructor for the edX course that we released on edX, which delves into large language models, applications, and also theory. We'll talk about that a little bit later. I do want to pass over just briefly to Ben before we move on, just to sort of build some context for why we're really fortunate to have him here and his perspective on this too. So Ben, do you want to just jump in for a moment?
Yep, perfect. So again, it's an honor to be here. Anytime Rob asked me to jump in and support, considering all the work he's done and continuing to do, and providing universities like Bowie State University as well as Johns Hopkins University, which was just such great support on the Databricks side, but also just ensuring that the students have the necessary environments to build out the capabilities that they're doing to support them in their academic career. So kudos to Rob and University Alliance first off. But when you think about so I'm dual hatted, right? So I'm looking at it from and a perspective of how do we bring AI to life when you think about large language models inside of applications that businesses use on a day-to-day basis, but also from a perspective of a university professor to really, how do we prepare our students? And one of the positions that I have is I'm the director of designing trustworthy AI systems. And how do we prepare our students to think about deploying AI and ML capabilities, specifically large language models, and doing that in a manner in which you can provide, think about like the trustworthiness that's necessary to be able to deploy these technologies at scale, but also provide the usability that's necessary for those technologies to be adopted across these organizations. So part of what we do for our students is really focusing not just on how do you build and train a large language model, but the feedback loops, right, that are necessary where the end users are providing feedback to the large language models in order to provide trust, but also in a sense, we're empowering the end users of these technologies to be able to, be heard in a sense, right? They have an understanding that it's important for us to provide the feedback that's necessary to provide back to the data teams. And they're going to hear our voice and they're going to update these models, which allows you to get the trust, which increases the overall adoption, right? So it's bigger than just training and deploying large language models. It's how do you get them into the hands of the end users across these organizations so that then they can have the trust to use them? Because, as Sam mentioned, these technologies are new. There's not a sense of, how do we continue to incorporate them in organizations where, for an example, one of the things we did with Rapid7, which is one of our cybersecurity customers, is basically, all right, how do you get a large language model into a security operations center, right? And, cybersecurity companies are really risk averse. So how do you, start to, provide that trust that's necessary to give them the, what's necessary to be able to make decisions based upon the data from the large language model. So really excited, but I'm coming at it from two different perspectives. Thank you.
That's great. Rob, did you want to jump in just for a sec? You're good?
Oh,
okay.
I just wanted to make sure that the audience understands that Ben wears 3 hats. He's a father, he teaches, and he's the founder of the company AI Squared. And I like this slide to give you an idea of some of the implementations of LLMs in the commercial space. And it's great to talk about, the advances, but when it maps directly to business value, I think that's sort of where we're all oriented to. And I think the Rapid7 example of, I always smile when I see that. Yeah, they're pretty, those air gaps are pretty important. You can't just connect to a giant cluster in the cloud. They might have some issues there. So I'll turn it back over to you. Either Sam or Ben. So if.
Yeah, I do want to just sort of talk a little bit about how that relates to how we're here. I think in the last 10 years, or maybe even the last 20 years, with the developments in deep learning and AI, they were, I really think for the first time since maybe military technology, the advancements were not happening in academia as much as they were, and certainly with the pace that they were in industry. So you have, the Google, Metas, Anthropic, all these giant stars of the industry world producing all of the innovations, and just the pace of innovation really was something that astounded most people really in all of AI and deep learning. But I think we saw an extra level of exponential growth in these sorts of things with large language models and transformer-based models. And I think the key reason for that is really the business value. We see all of the applications that these large language models are developed for have almost a direct application in industry for some business value. In the early months of this year, I know personally, I would wake up, look at the latest news of what sort of development there was in large language modeling, and then almost straight away you see some kind of product or some kind of innovation or startup that's founded based on that new innovation. And we just had this huge wave of different techniques and different research advancements happen, but they didn't really happen in universities. They did happen in universities, and of course people are researching these things every day, doing dissertations on these sorts of things as well. But there's something a bit different about AI and generative AI right now. I think in the last year and a half, that it's really taken place. The core innovations have happened either in universities directly partnered with large companies, or they've happened in the research divisions of large companies. And so we've come to a point now where, if you were focusing on something 12 months ago and then just stop looking at that and now look at the world around you now, it's completely different to what it was even 7 or 8 months ago prior to the launch of ChatGPT, arguably. And the reason for this astonishing pace is just that things have exploded. They've taken off in a way that hasn't really happened before. If you look at the amount of users of ChatGPT, it took less than 5 days to get to 1 million users. And that's just gone from strength to strength over the last 3 or 4 months. Every few weeks or so, OpenAI releases an update that just makes ChatGPT more usable, more user-friendly. From the point of view of things like the API, it gets cheaper and cheaper, and it just gets so much easier to use. And then if you marry that with the fact that the open source community is also making great strides to improving how large language models work and how well you can incorporate them in different applications, we end up in a scenario where things have gone very quickly, very far beyond perhaps the pace of academic adoption. And so we see, you have the august moving pieces that perhaps don't move as fast as they could in academia, but the students really don't see it that way. They'll take whatever is out there and apply it and solve the problems that they have to solve, or come up with ideas that they need to come up with. And so this really brings somewhat of an existential crisis to academia. What do we do? What's going on right now? And Ben, I wonder if you have any insight into what you've seen with things like ChatGPT, doing people's homework, or how much you've seen that adoption in the last semester or two.
Yeah, great question, Sam. And so we're seeing it from two different angles. I mean, think about the students being users of the technology, but also, from a computer science and computer technology perspective in the two departments that I serve within, it's really, how do you lower the barrier of entry for students to start to, create these technologies themselves? And, for us, as an academic institution, we're all about, how do we prepare the students for the next wave of prompt engineers and AI and machine learning engineers that are necessary to be able to go into the workforce and be successful. So there is a barrier of entry to be able to start to utilize and exploit these models. So I think one of the really cool things that we did with our students was Databricks has the open source DLite project, and one of the things that we were able to do is to leverage that as a way to lower the barrier of entry for our students to start leveraging large language models, right? So a GPU, right, of resources in the Databricks environment would allow your student in less than 30 minutes to start exploring, right? It's not just the model training itself, but what type of data, right, do you need from a question answering pair perspective to be able to tune a previously existing model to get it to be able to help you, right, solve the problem that you have for your research. So it's not just and a lot of people will think like it's just the model that you need to tune, but it's a lot of data engineering before you even get to the step of prompt engineering. And then there's additional technologies out there like LangChain, which allows the students to start pointing to other additional data sources that they want to combine with the prompt to get even more personalized responses. So our goal as educators is really lowering that barrier of entry and getting our students the skills that are necessary to prepare them for the workforce, where there's prompt engineers coming out and a year ago, as an AI professor, we didn't have to prepare our students for that. But now we're in this space where we have to have our students ready to be in the workforce and be successful.
Yeah, it's certainly been a very rapid change of what the industry needs and what academia tends to provide, though that's certainly going to have to catch up pretty quickly. I think also one thing that's worth just circling back on and making sure they're all on the same page here is just what LLMs can be used for. It's not just for a chatbot. A chatbot is one of the most natural use cases of interacting with a very advanced piece of technology, and so that's really penetrated the sort of mind share. I think most of all, OpenAI releasing GPT-3 as a chatbot, I think was a very shrewd and clever way to penetrate the different types of use cases. We had people writing poetry, people doing all kinds of different creative things with it. People thought that the sort of creative realms would be safe from things like generative AI for many years, but then DALL-E comes out and you can generate images and all these sorts of things, and so art and non-STEM topics are also not safe in some ways. But large language models, they can classify things. They obviously are good with knowledge answering. They have a vast array of knowledge that they're trained on, and so they can in some ways use that as kind of like a database lookup, though it's a little bit more fuzzy with large language models. They're also fantastic at translation. You know, if you've used Google Translate, for example, that's based on an LLM. And then generation, you know, dialogue generation, idea generation, these sorts of things, large language models are also very apt at as well. And having a very simple interface to use them by means of, say, ChatGPT or all of the different things you can do with Hugging Face and Anthropic and all these others, and AI Squared as well. Of course, make it so that it, like Ben was saying, the barrier to entry has just gone so far down now that people that would, you know, have no idea what a language model is are using LLMs every day. And so I think that makes it really vital that we provide tooling, that we provide infrastructure to face that challenge, because there's a number of different ways that we can go about dealing with LLMs in academia. For just like a brief overview, a language model is just a model that is given a list of words, and its job is to produce a probability distribution over all of those words, those are being its vocabulary, and it just selects what it thinks is the next best word or token, if you like, token being either a word or a piece of a word. The language model just produces a probability distribution and picks whichever word has the highest probability of being next. In most sense, that's what at least what generative models do. Non-generative models, classification models, also do the same probability distribution, but it's not predicting the next word. It's trying to say fill in a blank or a missing token. So all a language model is doing is just looking at all of the data that it was trained on. It just the loss function, the challenge that it had was just to what is the next word in the sentence. That's all it ever does, is produces the next word. Out of that fairly simple target of how it's meant to work, we find, you know, giant large language models with billions of parameters being able to do some pretty impressive things, even though fundamentally all they're doing is predicting the next token. That means that while large language models can do things that previous deep learning or AI models couldn't do, so just the fact that it could do these things is very novel, it doesn't mean it's perfect. And far from it, these models have flaws. They have you know, idiosyncrasies that we need to be very mindful of. It has some traps in it. You know, think about things like hallucination, where it sort of makes things up, or it extrapolates in ways that it shouldn't do, or it, you know, fabricates things. And then, of course, the whole issue of bias and offensive and toxic language that a lot of companies put a lot of effort in to try and minimize, but that is still very much a feature. Is also something that we need to be training in the students, but really any user of these tools to know that it's very powerful, but it's not perfect. It'll make mistakes. It'll have some flaws that we need to be mindful of. And, you know, that's as true for industry as it is for general users. And I think making sure that we, you know, appreciate that these things are powerful but flawed is really important for students who won't have the vast, you know, experience of seeing new technologies come and go. They'll, you know, see these things as new, exciting things that they just want to play with, and might be under the impression that it can solve all of their problems for them, because it certainly can do some things that no other piece of technology can do at the moment.
Hey, Sam, just one quick question from student. What's the relationship between a word and a token? Just
yeah, I can answer that. Ben, did you want to run with that one?
Yeah, so yeah, great question, first off. So if you think of, you know, so fundamentally when you have a document, and, you know, one of the things that, you know, we teach in our AI course is, you know, tokenization, right? So what you're doing is you're taking a document and you're tokenizing the document, because the way that, you know, natural language processing algorithms work really well is they don't work really well over information that is kind of, you know, joined together in a way where you can't interpret some of the intricacies of these different characters, right? So if you've heard of something called engrams is a way that you can kind of tokenize even further at, you know, you can tokenize at the word level. You can combine multiple words together, or you can tokenize at the character level, right? So what Sam is really referencing is like from an n-grams perspective, you can bring 1, 2, or 3 words together, or you can tokenize 1, 2, or 3 characters together. But what it does is it provides more variance, right, for your model. And the more variance you have in your model, the more well fine-tuned that the model will actually be. So the key there is you can tokenize at different levels. Tokenize from the words, you can join multiple words, or you can tokenize at the character level, but it adds the variance and it helps you get a more purpose-built, more fine-tuned model. But that's a really great question. Really great question.
Yeah, and also one other thing I'll add that Ben just to add to what Ben said is that tokens are also the way that we go from natural text to numbers, and so that the models themselves can interact with words as vectors. So so there's 2 sort of processes that happen in tokenization. One is you chop up the words to some meaningful level that helps with what you're doing, but then you associate each of them with an index. And then what you do when you actually give words or tokens to your large language model is it's just a sequence of indices. So 1, 7, 505, and then it just learns the relationship between these indices, and then the tokenizer, which is like a special function, turns it back into the word. So there's a one-to-one mapping there as well. So the question then becomes, and I'm sure many of you are on this meetup to be trying to answer the question, how the heck do we handle teaching when ChatGPT just gives students the answers, that can produce stuff that is more or less indistinguishable from coming up on your own. If we have a coding assignment, even it just gives you the code output. So what do we do? It's a very real problem. It's something that I'm sure all of you are either have colleagues of, or at least yourselves are trying to deal with this. And so it really comes down to 2 different approaches, really. The embrace versus the defense of large language models in academia is something that has not been settled yet. Some notable places have tried to just ban it completely, just say you can't use ChatGPT for anything or any AI tool. If you do, there'll be penalties, or maybe they use ChatGPT to try and identify if students were plagiarizing in certain ways. And I think the defense approach is understandable and natural. And I think that's probably acting very quickly. Defensive is really the way you can go. The problem is, though, being defensive like this also loses sight of the fact that these are imperfect tools, but also that they are just tools. When you think about the introduction of the calculator to academia, that also had a very huge impact. I certainly remember not being allowed to take my calculator into certain engineering exams and all these sorts of things. And that's 1, showing my age, but 2, making it clear that comparing LLMs to calculators is perhaps a bit of a specious argument, but there's a lot of corollaries there, that it's a tool, it's something that the rest of the industry, the rest of the world will be using as soon as they step out of academia. And so as educators, our role is really to prepare them. And we might have to let go a little bit of what we hold dear as, oh, it was better when we did it this way. That notion, it may need to soften a little bit so that we're preparing the students for the future, where ChatGPT will mean that the minimum level of what people can achieve on their own is now so much higher than it was 12 months ago. Back when we were looking at, say, full stack development and tools like Node.js and these sorts of things were coming along, it took a group of maybe 5 people to build a web startup that used to take maybe 20 or 30 people. LLMs have taken that down another order of magnitude, where you can, show a piece of paper for an app that works just by sketching it out, give it to ChatGPT with one of its plugins, and it writes all of the code for you. It can sign up the databases for you, it can do everything for you, and you just click start and you're off to the races. But that's a very contrived example. And if you really wanted to make that work, you would need to have checkpoints. You need to check on if it's working, if it does what it needs to do, and these sorts of things. And so I think, moving forward, we have to sort of pick whether or not we want to embrace tools like ChatGPT, or if we want to defend against them, or maybe a combination of the two. I think when we're in a certain environment, maybe we're in the computer science environment, or very deep into these sorts of tools, it's very natural to be okay with using them because you're aware of their flaws, or you're aware of what it looks like when they produce results. But for a lot of, for 90% of other university subjects or classes that aren't, deep into this NLP deep learning area, using these tools could be pretty indistinguishable from just someone doing well on their assignments. And so I think introducing these early and getting used to them is going to be probably the best way to approach this, and also give students from a vast array of backgrounds and what they're going to do in the future the ability to use these things, to leverage these things to be better than what they'd be able to do without it, perhaps. Ben, do you want to jump in here with how you see this sort of embrace versus defense?
Yeah, Sam, you are hitting on some extremely important areas. And one of the things when I think about, because as a university professor, one of the initial thoughts I had is, oh gosh, right, all of the papers and the reports that we've traditionally given to the students, case studies and all these different things, the students are going to use this technology, and they're not going to get the core learning that's going to help them have the knowledge that's necessary to be able to go into the workforce and be successful. And one of the things that that we started to, as faculty in the university, started to have to grapple with and overcome, is that unfortunately a lot of the repetitive tasks that we see currently on a day-to-day basis for a lot of industries are going to go away, right? But what is going to stay is those areas where it requires a very deep human connection and collaboration to be able to be successful in some of these job opportunities and in the workforce. So, if you think about it from a university professor perspective, what we're thinking about is, all right, how do we continue to increase the level of connection that the students have to have with each other in order to be successful, to derive new ideas and new concepts for different areas, right? So, you think about, the cross-project collaboration, right? Students usually are used to working on their own, right? And one of the things that we're trying to do now is we're trying to make sure that students understand that this deep connection and collaboration that you're going to have with your peers is going to be something that's going to be able to keep you, in the workforce, right? And keep you continuing to have a certain skill set that's going to enable you to be successful in the future as well. So, thinking about like individual project versus now, we want to make sure that the students are collaborating and engaging with each other and have the necessary, understanding and knowledge of how to build those human connections, because that's what's really is going to be able to empower them to be successful in the future. So that paradigm switch is a lot different, because it's easier to be able to have 10 questions and post it out there as a discussion and have them answer those. But it's more difficult to set up a collaborative discussion and set up a collaborative project and a collaborative engagement. But that's what we're seeing, is kind of that paradigm swing from before and after.
Yeah.
And yeah, it's interesting as I'm listening to this, Sam, something you said a couple of slides back really resonated with me. When we look at the use of cloud computing, when we look at Hadoop, when we look at some of these radical changes in storage and compute, I'm like, oh yeah, all of that came from 98% industry with some academic papers published. And so in my role, sort of trying to connect the tech world to academia, it's like, oh, that's why there's these sorry, I have a little helper here. We have these entities shifting at different speeds, and this is this is probably the most extreme example I've seen, to where I love that spike of how many users in the first day. We have 25 minutes left in this session, so I want to do two things. One, we've got 30-something people on the call. I think we're all well trained in Zoom etiquette. We can use the chat window, or we can just, you can unmute yourself and ask a question live. I'm happy to sort of do some triage there. But the other thing I wanted to say is, and I had one question in chat that's like, this is great. I'd like to get a job in this industry. What can I do? And so, Ben, you set up the next slide perfectly. And Sam, I'm going to turn it over to you. And I'm just going to say this is a shameless plug for an LLM on edX that Sam is actually building and running. So this is an implementation for somebody on the call who might want to say, I would like to know more about this. I would like to get a certification, and I would like to put this on my LinkedIn profile and help me get a job in this industry. I'm going to turn it over to Sam. This is marketing, but it's also useful. But what I want to get out of this after Sam talks through the next slide is, yeah, that's great. But I'm Lloyd, and I'm teaching at the University of Rochester. And what does this mean to me? So I'll be quiet, turn it over to Sam. And when you're ready, Sam, kick it back to me.
Yes, it's a very subtle kick to timing there. So yes, shameless plug. We just launched our edX MOOC on large language models. We have 2 courses, applications through production and foundation models from the ground up. The goal of this really was, we looked at what was being offered when we started this, and there wasn't a sort of cohesive set of building blocks for LLMs kind of from 0 to 100. You have specific, very well-made pieces that are very specific to perhaps, lane chain or just vector databases or LLM ops or these sorts of things. And so the goal was we wanted to create something that was sort of overarching, that you could take this one course and then you'd be pretty much up to speed, or at least you have a strong foundation for all of the things that are changing in both the application space, but also the foundation space. And there's a lot of really interesting innovations in each of them. We launched course 1 last week. We've got over 8,000 enrollments, which is fantastic. You can audit it for free, and you get all of the slides and the notebooks. If you did do the verified track, we give you access to quizzes and Databricks workspace, where you can run the notebooks on CPUs and GPUs, and so you can do some fine tuning. You can play with LLM agents and all these really fancy things, and build your own vector databases, all this really fun stuff. So very much, if you're interested in just doing sort of a deep dive into what LLMs are and what a course might even look like on LLMs, please check that out. However, like you, I wanted to teach LLMs rather than learn LLMs. So let's talk a little bit about the larger point for this meetup, which is really what you can do as educators and maybe what we can help with to provide resources, or at least to hear what you might need or what you're looking for. So I just want to sort of move on now to what Rob was alluding to, and Ben and I can help out, hopefully field some questions about the toolkit, really for faculty wanting to incorporate large language models into their curricula, to think about how you might teach or broach the topic of LLMs for your students, both in terms of tooling. So that might be notebooks, but also content. Maybe these are areas that you want to look into, but you're not sure which ones, or like an a la carte option or really a prescribed option. So maybe we'll open the floor, or Ben, if you had anything, or Rob, to say. All good? Yeah, Rob, please.
So since I know a fair number in the audience, I may just ask maybe Scott Jensen, San Jose State, if you have some thoughts on bullet point number 1. What do you think about LLMs in the academic space? Everybody who knows Rob is like hiding now. It's like, no. Take it away, Scott, if you have something you'd like to add here.
Yeah, I'm interested in seeing how we can use it. I teach undergrads in an MIS program, so to some degree, sort of the third bullet point of saying what sort of resources would be available, and I haven't had time to look at it. I know Databricks had something that had come out fairly recently on this, an open source model that I saw said it could work on a smaller set of data than some of the really large ones. And so I'd be interested in hearing more of that. The resources like the community edition that you have for Databricks for the undergrads works really, really well for me. And there's another plug for another talk you have coming up this morning, where if they can get resources for like $60 a student. So that kind of thing would be awesome, I think.
Mhm. Yeah, I think you're referring to Dolly for the model that we recently announced or recently released. It's yeah, I think smaller models are certainly very helpful in academic settings because you don't want to be burning GPU hours for no real reason when it's more about an education experience than getting the 99th percentile of some benchmark or something like that. It's really not as useful. Yes, so when Databricks released and published about that model, rather than being a model that could be competitive with the leaderboards of all these sorts of things, the goal of that was really to show how democratized we could make AI and how much you can use maybe a model that's past its prime, maybe it's a little less relevant than now, but if you give it some high quality data, but a small amount, you can turn it into something that's very useful. And so as an exercise in what fine tuning is, in what just language models are in general, that kind of approach, I could see that making a lot of sense for it to be a smaller model that can do most things, but really just conveys the sort of the wisdom of the teachings rather than a specific use case. Yeah, I think that's very, very important. And Scott, you also mentioned the community edition for sure, or working with partners like Vocarium to provide these sorts of environments, which is something that we want to get to. I will make, I do see there's a question. I don't believe there's GPU access in Community Edition, but there are plenty of things you can do with CPUs, with large language models. In fact, the edX course that we have, we actually tried to build the entire course on CPUs. We do use GPUs for one module just to show that you can, but otherwise you can do a heck of a lot with CPUs, which is good to know. Certainly for education.
Yeah, and I'll talk a little bit about forward-thinking architecture, and this is, Scott, to your point about Community Edition. I think every faculty who's taught a course using Community Edition is used to the fact that once in a while there's just this indeterminate or unpredicted slowdown, and you just have to just take a deep breath and wait a day or two for things to settle down. In about a year, the system that is running behind the scenes on the edX course is sort of the predecessor of what comes next in terms of Community Edition. So in about a year, we should have something that is the next version of Community Edition, which is basically a credit-based version of full access to Databricks, so that there's no difference between the quote, the next version of Community Edition and the full Databricks platform. It's just you have a set of credits that you can use against a specific set of resources. And so, behind the scenes, I'm advocating for it. Well, if I've got an EDU or if I'm a qualified university, the amount of credits you get, it re-ups every year that you're either a student or a teacher, and it covers that there's 95% of the use cases. So Scott, you mentioned the $60 per student per semester, something like that. So we're in working with Vocarium, we've got pretty good boundaries around what that 95% interval is. So know that in about a year, or I'm going to move on and go become a bot somewhere, we will have a fully functional Community Edition that covers 95% of what students and faculty need to teach a full-featured class on the entire Databricks platform. That's been my goal for 3 years, and I'm kind of excited to see that possible. So yeah, Matt, specific to your question, no GPUs in Community Edition, but with Vocarium, you can actually get access to GPUs. So we've got a session that's going to happen in about half an hour, talking about, and it's the next event on the meetup, talking about how to do this. And I think we've got Lloyd used Vocarium last semester, and I think we'll have maybe 20 to 30 courses using Vocarium in the fall, or at least the next academic year. Yeah, a year is a long time. Try 3 years. 3 years is a long time. It's all good. It's basically we're trying to get commercial grade tools out to students at scale, and there are hurdles in the way. I think I would, Suhong, I may, she's like, oh gosh, somebody Rob knows, if you could give us a little bit of perspective on bullet points number 1 and 2. And I'm asking Dr. Lee to talk here because she is one like Lloyd, to where she is connecting students with industry problems while they're in school in a capstone format. And I'm curious to see from your perspective, are you seeing a pull from industry via LLMs, or do you think that you're going to try to move to where the puck will be so that you're teaching it and then there's the pull? So.
Hi, Bob. Can you hear me? Yeah, sure, great. So actually, I do believe like a large language model has a place in academic space, because this is where the industry is moving. There's so many people are using it. I believe actually I create OpenAI. I have an API account. I have developed some amount of applications. The recent one is use OpenAI with the LangChain for student input a data set to ask different questions. I have incorporated in my MBA course. I'm teaching MBA like applied analytics. So I think currently I'm worried about is all the because I know this is fantastic technology. People consider it's going to a disruptive technology. It's going to change a lot of things, but there's a lot of doubt, and people even say maybe this technology is going to take over the world. Is too intelligent. So I'm worried about even when incorporating the academic space, even my student has doubt. So how we deal with all the we say the AI bias, because it's built into the data or label. So is there any because we teach students how to use the technology, but we also need to be very careful about how we educate the student the possible bias or the negative impact of this.
That's a really good point. And I think, one of the things that we see in the industry is it seems to be concerted effort, especially this year and last year, is the ethics in AI and how much, to their credit, OpenAI does seem to be putting quite a lot of effort into making sure that, a model with zero bias, using a very technical term, a model with zero bias is completely useless.
Right.
And because it will just give an average answer to everything. There's a very fine line between a good bias and a bad bias, and there's probably no such thing, honestly, as a good bias. We'll probably see that these models will differentiate over time for different maybe communities or geolocations or something like that. And I think just teaching the nuances to students and maybe just more analysis into the biases might be useful. And actually, Ben, I wonder if you might be able to speak a little bit to how you can deal or at least recognize LLM biases and how you might train against them or protect end users from it.
Yeah,
that would be, I think, important, very interesting direction. Can we do any work? Maybe we can reduce bias, or at least maybe build the confidence of the user, because right now some people trust content, some people totally don't like it. So we need to give people confidence. Maybe there's some type of validation, and then we can validate a result output from it. Can we trust? Because even I'm analyzing the data, they give me a graph, I say create a bar chart. For me, I really have a doubt. For me, I like to run my own analysis. So how we know they are right, they are correct? What if they make a mistake? If people using this software to make a mistake, they're going to lose trust. They're not going to trust this system anymore. So I don't know, it's a dilemma. I don't know how to solve it. I just throw the question out here.
Yeah, Ben, do you want to jump in?
No, I think this is such a great topic. So one of the things, this is really amazing because the challenge is that when you're working with your students and they're building these models, you're testing purely for statistical accuracy, right? Inside of a sandbox. So you're looking at things like, all right, what's the accuracy? What's the fluency? What's the coherence? Is it relevant when you think about the subjects based upon the questions. So it's purely from a statistical standpoint, right? Now, the challenge is when you get the large language model in the hands of real users, right? How do they actually view the answers as being related to the statistical accuracy of the answers? And a lot of times what we see is it's totally different when you actually get the results into the hands of users, because even though the large language model provided a result that was true, right? Maybe it wasn't relevant to the question that you asked, right? So what we're starting to see is that it's so important to go the last mile with the students to actually have them interfacing their large language model with other students so that the other students can start to give them feedback on the accuracy, the bias, the fairness, all of these things that we want to learn and understand and know about the large language models. You can't really get that until you have that collaboration and that human interaction with other individuals that are in the class, maybe to actually test the models that have been built. So one of the things that we do and that we've done is, and if anyone's interested in this, please reach out to me. What we've done is we've taken the DALI model that Databricks built, and we put it inside of a browser extension. So now you train DALI, and now you can actually put it in a browser extension and you can actually test it with your students, where other students in the class can give feedback for how well your model is doing, right? Thumbs up, thumbs down, and additional information to say, hey, the model was right in this instance, but the result was a little biased in a sense, or wasn't fair in a sense, right? So that piece is so important, but in a lot of classes, we don't get to that piece because we're still focused on statistical accuracy, and we don't go the last mile to get an understanding of how well it's actually being used with a user base, and that's really important.
Yeah, makes sense. Thank you.
Yeah, I'm just those of you who know me well know that my father's a retired English teacher, and he's 93, I think, as of yesterday. And I'm kind of glad he was a strict grammarian, and we would have to diagram sentences, when I was 8 years old, and sort of that human aspect of learning and the reflection part. I think it's easy to get caught up in algorithms and models and optimization, but the forced reflection, I think, is something that's a critical piece of all of this. And without the forced reflection, we're sort of running down the Robert Oppenheimer, path of, fear the technology, and it's going to exist. And what we need to do, I think, and I'm sorry, I'm editorializing, but it's the mandatory human reflection part of what the model is doing. And maybe that's a call to action that comes out of all of this, is make sure that whatever we're doing, we're using our peers, we're using, other classes, we're using, human beings to say, what do you think of this? And without that, I think there is this sort of, runaway AI fear that has some legitimacy to it, not in terms of Skynet taking over the world, but in terms of the AI becoming tools for inhuman goals and subjecting human beings to inhuman tasks. So that is one fear out of all this. Yes, it's changing industries. How do we, one, provide a path for people to take advantage of it so that the jobs that they're doing become more human, and we're offloading, say, hey, Rob, go write a device driver. Like, yeah, no, we can accomplish that via other means. Hey, Rob, go work on an interesting intellectual problem. That's a better outcome. So from that, I just want to ask a very specific question. If you're going to teach LLMs and you saw Sam's slide on the edX course, one of my jobs, literally, hey, Rob, gets paid to do this. How do we create assets for faculty from the content that Ben and Sam have created? It's like, hey, you want to go teach some of this stuff? and I'll put my email address in there as well, but just tell me, it's like, what are your learning objectives? If you're going to teach a course on LLMs, give me your 5 learning objectives. Tell me, and I'm not me specifically, but as a mouthpiece for, you know, the 500 plus faculty in the University Alliance and others on the call, like, hey, let's get some learning objectives together and let's see what sort of, you know, openly usable resources we can put towards that. The next session on Vocarium, great, you can access GPUs. You don't have to worry about connecting to AWS. It's sort of all out of the box from Vocarium. That's great. That's the technical platform, but what about the, you know, the key intellectual pieces behind it so that we can spend less time doing the technical scaffolding and set aside that 20 to 40% of reflection time at the end. So focus on the cognitive and the reflection versus the, how do I put the tech stack together? I mean, which is useful in terms of functionality, but we've got tools. Let's rely on the tools to do that and get to the more human part and cognitive delta part. Oh, my email address. So make sure this goes to everyone. So, and now just what else? Anybody have anything else they want to say or comments or anything? This has been an amazing session, and I really appreciate your attention, and also Sam for structuring the content and the flow, and Ben for you know, jumping in and connecting this to some real world activities. And yeah.
Thanks, Rob. Thanks, everyone. Yeah, I mean, we're really interested to hear what would be useful to you. We have some ideas of, you know, what we're going to look at packaging. You know, we have some great people to talk with that have already given some insights. But, you know, we really want to hear from all of you on the call, all of you watching after this is live. What, you know, help me to help you. Like, what will it take to make this an easy transition? You know, what do you need to leverage this so that you can go and do what you do best and teach these new technologies? Yeah.
Sam, could you do me one favor? Can you
Yes.
take the Google slides that we put together, or you mostly put together for the session, and put them in a publicly shareable link, so that, I mean, if you're okay with the slides being in the open domain, I would love to put a link to the Google slides and a link to the recording of the session in the meetup.
Absolutely. Yeah, absolutely.
So, and again, it's a little wonky, but when the meetup is done, the recording gets saved. I will upload it to YouTube. So that link will go in the comment section. And then once I get the shareable slides link from Sam, then I'll post that in the comment section as well.
That's
calls to action. What presentation would not be complete without calls to action at the end? So I put the edX course link in the chat. You can just email university@databricks.com or rob just rob@databricks. Can't speak anymore. Too much coffee. And we've got a LinkedIn page, and then also a general meetups page for the University Alliance. So I'm trying to get away from emailing people stuff and then just getting it posted on the social media things so that you can, you know, consume it as you're able. So and there is, I'll put one more link in the chat window. If you're in the Bay Area, there is a giant LLM focused event happening. And I just want to put it here. And this is Ben will be a speaker at this event. One of our founders, Matei, will also be a speaker at the event. And it's just an LLM focused event. And I know at least 3 or 4 people on the call will be in San Francisco as well. So yeah.
Yeah, that's going to be great.
Okay, we're going to wrap a minute early. Thank you, everyone, for your feedback. And by the end of today, I'll have the slides link and the YouTube link of the recording of this event, complete with all my verbal miscues and the awesome content from Ben and Sam. So appreciate it. Take care.
Thanks, everyone. Thank you, Ben. Thanks, Rob. Thanks, everyone.
Sam. Thank you. Awesome, man. Thank you. All right, Rob. Thanks, everyone.
Take
Bye,
care.
everyone.